Hi, I'm Craig Smith, and this is Eye on AI. I heard from some far-afield listeners after my appeal last week, but none from Nepal, Bangladesh, or Kazakhstan. Come on, people, send me some love. I'm wanting. This week, I'm doing something different. Our guests are the hosts of another popular AI podcast, AI Today, produced by the team at Cognilytica. And they are having me on their podcast at the same time. So if you want to hear me opine instead of just asking questions, go over to AI Today and listen in. I encourage all my listeners to subscribe to AI Today, which is an excellent podcast, and leave a review for them on whatever podcast platform you use. The likes and reviews honestly make a big difference in attracting new listeners. Ron Schmelzer and Kathleen Walch founded Cognilytica and have grown it into a premier research advisory and education firm focused on evolving areas of artificial intelligence. They track tens of thousands of technology vendors and provide services to enterprises of all sizes. I'm a great admirer and turn to their reports often. Ron, Kathleen, and I talked about the rise of MLOps, data labeling, unsupervised learning, and what it will take to get us to human-level artificial general intelligence. Both Ron and Kathleen had some surprising insights. I hope you find the episode as informative as I did. One of the reasons I'm interested in talking to you guys is you have tremendous coverage and very deep coverage of what's happening in the ML space. I tend to cherry pick depending on my interests, primarily with basic research, but you guys are much more complete. Could I have you guys start by each introducing yourselves?
Well, first of all, I want to thank everybody who's listening to us. We're thrilled to be on this podcast. I'm Ron Schmelzer. I'm a managing partner and principal analyst here at Cognilytica, and we're a research advisory and education firm focused on the universe of AI and machine learning. We've been adding more on automation as well. That's a very hot area, and even more advanced analytics. Maybe, Kathleen, you want to introduce yourself as well?
Sure. Yeah, I'm so excited to be here as well. I'm Kathleen Walch. I'm also a managing partner and principal analyst at Cognilytica. As Ron mentioned, we're an AI-focused research advisory and education firm. We track many vendors in the space, over 20,000 actually. So, we have a good pulse on what's going on, what markets seem to be expanding, which ones are contracting. There's lots of deals happening as well. So we definitely have a pulse on all of it. And then in addition to that, we also have our own podcast called the AI Today podcast. We're excited to always be guests on podcast. And for Craig's listeners out there, he will be on our podcast as a swap. So we encourage you to check that out if you're interested in hearing what he has to say when we interview him on the AI Today podcast.
Wow, you guys are good. Okay. Much better than me. I've looked sporadically at machine learning platforms. I'm interested in the tooling behind machine learning and how machine learning models get built. You guys track over 100 vendors involved in the space, from toolkits and notebooks to machine learning as a service. My first question is the market saturated? And without picking winners, what products do you see rising to the top?
It's actually good that you're asking us this question right now, in the general timing of the world, because here we are. For those who are listening to the podcast, it's August of 2021. People might be listening to this podcast a year from now, so this will all seem really quaint to those in the future. But the market's actually in the midst of a consolidation phase. We're actually starting to see a lot of acquisition activity, and we do track over 100 vendors in the machine learning platform space, about 72 of which meet the minimum threshold of viability. There's lots of startups in the space. We love startups. We have an affinity for companies of all sizes. But when we're looking at companies who are buying products and services, we tend to look at those companies that have either at least 10 customers or have at least 10 million in revenue or at least $10 million in venture capital.
The 10.
If they have like 2 customers and no venture funding raised and a little bit of revenue, then we're like, just grow a little bit more. I mean, we love you. Just grow a little bit more. So there's about 72 companies at least that are in that genre. Of course, all the cloud vendors, are in that space. The major cloud vendors, Microsoft, IBM, Google, Amazon, and a few others. So those are what we call the cloud SaaS, machine learning as a service vendors, basically. And then there's a whole other category of pure play machine learning platform vendors. So you may be familiar with DataRobot or Dataiku in that space, a bunch of others that are kind of trying to pull together all the components of what's required to put machine learning and advanced analytics solutions into play. And increasingly what they're doing is they're growing through both building out their product suites and through acquisition. Especially DataRobot's been on a tear lately. Dataiku as well has been really growing, and they raised a very significant round recently. But the answer is that this market is actually starting to condense, right?
Right. Yeah, we're definitely seeing that. So we've been tracking markets for a number of years, and we have seen, like Ron mentioned, this market in particular as one of the markets that is contracting. There's still a lot of companies in the space, but as Ron mentioned, there's a few that in particular that are really acquiring a lot of other companies, and we're starting to see it shrink. In addition, the few companies did go under, somewhat surprisingly to us, but in general, most of them are getting acquired.
Yeah, within that, MLOps is a subset of that platform and tooling space. It's actually growing from what I can see. I'm constantly getting contacted by people with a new startup. It's, from what I can see, increasingly crowded and frankly confusing because there's so much overlap.
You're right to be confused, by the way, because it is confusing, even to those of us that spend all of our time in the market. It actually just connects to the previous question, because the idea is like, what does it really take to put a machine learning model of any type into production? And it turns out there's a lot of pieces. One of those pieces is just dealing with data, getting data prepared. So there's a whole data preparation space. Then we may talk about this later, which is if you have the data to make certain kinds of machine learning work, like supervised learning, you have to tell the computer what stuff is. It can't look at an image and know there's a cat in there, right? You have to say there's a cat in this image, and that's what you're doing. You're labeling the image and say cat. And in many cases, doing even more specific things in the image, if you're trying to do more sophisticated things, right? Then you have the whole building the model, training the model. And there was this whole movement towards trying to simplify that, because data scientists are a little hard to come by. Not all organizations can afford them, but also a lot of things we're trying to do don't really require sort of building everything from scratch and, going right down to the lowest levels of the algorithm. Some companies pioneered this area of Automl, which is trying to automate a lot of these aspects. And that really has helped. And there's a lot of stuff there. And then once the machine learning model is sort of produced and tested and evaluated, which are whole other sets of steps, you have to get it out there, the model, and you have to also manage it, because these machine learning models, they evolve over time. And the whole space of MLOps is really about trying to manage that life cycle of the machine learning model once it's kind of out there. Models drift, data drift. And so there's a bunch of these vendors who are tackling this problem of managing the machine learning model in operation. That's the whole MLOps space. Kathleen, we could talk about some of the vendors in the space and kind of how we see it sorting out as a starting point.
We do see it growing as well. There's a lot of companies in this space. I think that from a market standpoint, people need to educate themselves on what particular vendors are really saying. As an analyst firm, we need to cut through the marketing spin and say, okay, what can this product really do? What does this company really do? And they, as a whole in this space, don't always do a good job of helping people really understand that. As Ron mentioned, we have covered this space and we have produced a report on it. And then our new website has updated continual coverage on it. So rather than producing one large report that can get stale quite quickly, we will continually feed that. We found that in these spaces, especially some of these hot spaces, with all the acquisition that's going on and with fundraising that's going on, companies that maybe didn't meet our minimum threshold quickly will with these ridiculous rounds of funding that they're getting. And also companies can get acquired. We've seen a lot of that happening in the space, even if it was a rather large company.
So the overall tooling and platform space is contracting. There's consolidation beginning.
Consolidation is probably the right word. Contracting, people might think that the market is contracting, like spending dollars. That's not what we mean.
Right.
Sort of the number of vendors.
The number of vendors. That's what I meant too. But within that, the more granular MLOps space is growing. And I'll name a couple of companies that I'm familiar with. There's a company called Verta. It's built around a versioning tool called ModelDB. And they say that they're an end-to-end MLOps platform. But when you look at them, they pick up during the build process, and then they carry through to deployment and monitoring. But then there's a company called Determined AI. It's actually now open source. They also say they're end-to-end. They start after the data prep, largely in choosing architectures and hyperparameters through to deployment. Are developers using these products sequentially? Why don't they all join forces and bolt their products together and then have closer to a true end-to-end solution? Is part of the consolidation that's going on doing just that, taking these pieces, sticking them together, or is there value in having discrete platforms and tools that you can pick and choose from?
Well, that is a classic question for all software markets. It's always the question of, is the product a feature? That's what venture capitalists will ask you if you're trying to raise money. Like, I love what you're doing, but is this a feature? Meaning that this is something that will inevitably just be part of something else. Or is this a market? Like, as in it'll clearly be on its own for a long time. MLOps is maturing. It's a space that people didn't really talk about at all maybe 3 or 4 years ago. Now we're realizing how important it is. It's sort of like DevOps. We didn't really talk about much in the year 2000, but now with Agile and all this sort of stuff and continuous integration, now everybody talks about DevOps, and it's its own universe of stuff. The thing about MLOps is that some of the vendors have been acquired. So Algorithmia, one of the big players, was just acquired by DataRobot in a pretty substantial deal. They also acquired another company before that called Parallel-M, which was sort of in that genre. Kathleen alluded to a company that actually went bust, Dot Science. But those people kind of went off into working with some of the other vendors that are in the spaces like Pachyderm, Tecton. I think we're tracking about 40 companies in the space, 39, 40 in the space right now. There's a lot of people who do believe that MLOps is a feature of what will be sort of a more complete product. You know, right now, a lot of the cloud vendors haven't added too much in the way of MLOps. If you look at what's on the AWS, the SageMaker platform, or the Azure platform, or Google Cloud, or something like that, in that sort of universe, they're going to probably add that stuff. They're going to probably either add it through acquisition. They may pick up some of these companies, probably most likely Microsoft and is known to be acquisitive, Google as well. It's hard to see that this is going to be necessarily a long-term market. A lot of people believe that MLOps is a philosophy and it's a way of doing things, and that these tools can help. So I would say maybe 2 or 3 years from now, we might not be talking about a separate MLOps market category.
So ultimately, we're going to end up with a handful of true end-to-end platforms where you prep the data. If it's supervised learning, you label the data, you do a neural architecture search, you do a hyperparameter search, you build the model, you run the training iterations, and then you have a compiler that spits it out into the world.
In our ML platforms report, we actually talk about there's really 5 major platforms of how you build a machine learning model. If I said to you, hey, you need to build a machine learning model, and you had to go out there and choose a way to build it, you actually have 5 separate ways, if you want to think of it, choices. They're not alternatives. They're just They're just different ways. One thing you could do is you can build your whole thing in the cloud. You could say all my data's in the cloud. It doesn't make sense for me to take the data out of my cloud and bring it somewhere else and then build a model and push the model back in the cloud. You're saying, well, if I live in the cloud, I should probably build my machine learning model in the cloud. Those platforms are just going to continue to expand in functionality. It's going to make more sense if you're an Azure or a AWS person. You're going to probably stay there and you're going to do those things to the extent that the data is in the cloud. Because if the data is not in the cloud, then actually you can make a solid argument. Like, well, why should I put my data in the cloud? Especially if I have issues with it. If maybe I've got exabytes of data, moving data to the cloud is just painful, right? And then we have all these other issues of dealing with data that might be private and confidential and all that sort of stuff and secure. Number two is you could use an analytics tool. There are tools that have been around for decades. SAS, SPSS, which is actually now part of IBM, MATLAB, and they're focused on the needs of the data analytics. And if you're a data scientist who's been living in the data world and you need to build a model and you're used to the environment of analytics, you're probably going to stick with those tools. So you might build a model in R with R, Python, whatever, inside of one of those environments, right? So that's actually a second choice. The third choice is that you might decide that you are living in the open source world. If you're coming out of like being a Python person and you're used to using Scikit or all these things, and you want to continue in that ecosystem, Data Robot, they kind of build on top of the open source ecosystem and they allow you to sort of stay in that world. You don't have to move your data to a cloud environment. And also you could be vendor neutral. Different people maybe working in different environments, hybrid environments, can use the same tool to build machine learning models and in the same environment, and then push those models into different environments. They could take that model and push it into Azure or AWS. So it's a third choice. And then the fourth choice you can make is that instead of using machine learning platform, you can sort of pull them together yourself out of the pieces. A lot of researchers and academicians, and if you go to code academies, they're just going to like, here are the tools, you pull it together. There are reasons for doing each of those things. A lot of it has to do with where the data is, a lot to do with what your expertise is, a lot of it has to do with where these models are going to end up being used and who's developing them. You can have citizen data scientists, you can have experts. So I think we're going to continue to see quite a bit of diversity in product here.
I notice you have published a report on Labelbox, which is a company I'm familiar with. Those guys were on the podcast. Labelbox is a platform for labeling data. They're not a service company. They're a platform, and you can invite labeling teams onto the platform and manage them through the platform. I also had Alex Ratner on, one of the founders of Snorkel, which just raised a lot of money. And they do programmatic labeling. And from what I understand, it's kind of brute force computation that maybe is not as precise, but is good enough for very large projects. And then I've also had Dale Kim. He's a former colleague from the New York Times who has a company called AI Reverie, which does synthetic data.
Yes.
And then there are the BPOs in India. So how do you see labeling developing, particularly hand-labeled, programmatic, and synthetic? Will they all survive? Is the market going to continue to grow so that there's space for all of them? Or do you think that it'll go to hand-labeled data, and then depending on the size of the project, the rest is programmatic or synthetic?
That was another six-part question. I'll take some of it. Kathleen, you take some of it.
Yeah, I can start.
Yeah, go for it.
At Cognilytica, we have been covering the data labeling space for many years. In fact, before most people in the market were actually covering it or really understanding what it was about. So we have a great pulse on that space. We have seen from the beginning of when we initially produced our report, I think our first report was back in maybe 2018 or 2019 when we really started covering this space. We've seen a lot of different companies come into the market. So we cover a wide variety of vendors. I think we have something between 60 or 70 vendors that we're tracking in the data labeling space in particular. What we've seen is that companies from back in the earlier stages to now have started to specialize in what they do. So Labelbox in particular has just raised a pretty significant round, and we have seen the growth in this market tremendous growth in this market, but it's starting to show signs of definite leaders in the space, and people and companies that can raise money and companies that are struggling maybe will merge, maybe will get acquired, maybe will go under in the next, 12 to 24 months.
We divide up the universe. This is sort of the second part of your question. There are a bunch of folks who are providing the labor pool to do the labeling. So for those who are on the podcast who are not familiar with this idea of labeling, the idea is that if you want to train a machine to do something that requires recognition or even conversation, things like that, you have this little chicken and egg problem. Like the machine doesn't understand what it is, so it can't just learn on its own. Somebody has to tell it, the machine, kind of what the data is all about so that it could say, oh, here's 1,000 pictures of cats. This is a cat. This is a cat. This is a cat. This is a cat. Which is you take an image, which is just a bunch of pixels. A machine doesn't understand what it is, just a grid of pixels. And you say, this particular grid of pixels is a cat. This particular grid of pixels is a cat. And actually, if you think about it that way, it's a better way of understanding, because if I gave you a stack of 1,000 images with lots of pixels and say, all of these with these pixels, they're all cats. Now learn something, find the pattern, which is basically what supervised learning is. Find the pattern in those pixels where if I gave you a new image that had a bunch of pixels, you could tell me with what likelihood that image is a cat or not, which is basically what a machine learning system is doing with all that. But it can get more sophisticated than that. That's just like the whole image. What if I want to say, draw the box around where the cat is inside this image, or track the cat as it's moving in this series of frames in this video from one side to the other, or basically determine what the intention is. It's sort of cat jumping or person reaching on a shelf or, somebody scratching, now you're starting to get more complicated, right? Until the machines can figure out how to learn for themselves, which is definitely a holy grail of artificial intelligence. We are getting better at doing things like requiring less training data, learning from other examples, doing what's called zero-shot learning and one-shot learning. We've actually recorded some podcasts on that subject. Until then, you need to have this labor pool. Now, some of the companies in the space, they provide a labor pool, and you're right, a lot of them originate from traditional business process outsourcing firms or firms who have been doing other things with data. So what you might see is there are a lot of companies in the space that used to do, for example, content moderation for organizations like Facebook, where they have to go in and say, this is not good, bad content, NSFW, whatever it is, not acceptable. And, as much as Facebook and other organizations say they have an AI algorithm, for better or for worse, there's really armies of people who are doing that. Maybe they're validating what some of the algorithms do, or they're not really using an algorithm. And it's really tough work, honestly. And that work tends to go, of course, to areas of low labor cost. In the very beginning, people used crowdsourcing for basic labeling tasks. Amazon was one of the first to really pioneer this. They had a thing called the Mechanical Turk, which is a reference to the chess-playing bot Mechanical Turk. And actually, way back in 2005 or 6, Mechanical Turk came out, and you can do these little tasks for pennies, right? And it started for a very logical reason. When Amazon started selling music, they had images and they needed to get the stuff into their database, right? Somebody had to basically type in the name of the album and the name of all the people on it. OCR, as good as it was just not working on images because, first of all, crazy fonts, all sorts of stuff going on. It was just easier to say, go on here, get a bunch of CD images and just type in who the artist is and type in the other metadata. And that's actually how it started. And they're like, hey, typical Amazon fashion. They're like, well, if we need it, other people would need it. Why are we spending money on it when we could be making money on it? Let's make this a service. And Mechanical Turk for many years and things like it were sort of dominant in the labeling space. But then people realized that it's kind of not so great to rely on random people to do things, especially when you needed certain tasks like go in and label all of the street signs in Thailand so that I can train my autonomous vehicle to recognize stop and stuff like that. Well, you need to know Thai. You need to know what the stop signs look like in Thailand, which may be different. And that required more specialized labor pools. Of course, we have issues of confidential data. People are trying to label medical imagery. A lot of that medical imagery has protections and things like that. Of course, let's not talk about military intelligence data and all this other stuff. And that's where these new companies came out. Organizations like Allegion, which we've been tracking very, very much. We have some very powerful technology for doing video annotation. Scale, very heavy in the autonomous vehicle space. You can imagine who their clients are. They also got a pretty substantial deal with the government. They have some connections. I just want to say the former chief technology officer for the United States, Michael Kratsios, now works for Scale. It's a fact. I'm just saying it. So these companies are growing. Somebody's going to go public. As mentioned, Figure Eight, they used to be called Crowdflower. They got acquired by Appen, but then they spun off their federal arm because Appen itself is based in Australia. And you can't get federal contracting money, especially for certain areas if you're not headquartered in the US. So they've spun out Figure Eight Federal, which is here.
A side note on Mechanical Turk, Fei-Fei Li used Mechanical Turk to label the original ImageNet data set that Jeff Hinton used to validate deep learning. And so the reason we both have podcasts is because of Mechanical Turk, or at least Mechanical Turk played a role. I wanted to restate the question whether you have a view on hand-labeled programmatic or synthetic going forward. What's the future look like?
What we have seen in the market is that it depends heavily on the use case as well. But in general, a lot of that easy, low-hanging fruit has already been labeled. Synthetic data, we've really started to see use cases for this and say, okay, maybe I do want synthetic data for a variety of different reasons, maybe for privacy reasons. Or we had an example with Amazon, with their Amazon Ghost Tours, where they needed to have a variety of different poses from people of different heights and children as well. And they wanted them to stand at a store, put their hand on the top shelf, put their hand on the middle shelf, the bottom, maybe a toddler, trying to put something in the cart. To have people do that would be incredibly difficult and take a very long time. So they use synthetic data to help train their systems. So for examples like that, that can be incredibly useful. And we're starting to see synthetic data being used more as well with different applications. So it depends on what exactly you're trying to do with where things are going to go. We can't say, synthetic data is the wave of the future and that's what everybody will be using going forward. But I think that people are starting to see more use cases for it.
And then there's this whole question as to whether or not unsupervised learning will eventually overtake supervised learning and you won't need labeled data at all.
That's certainly one of the goals of a lot of research. Because if you think about our brains, if you put water in a cup and you turned it upside down, the water spills out. Maybe that's what you do when you're a toddler. You're like, ooh, look at all these cool things I can do. Nobody needs to teach what would happen if I put water in a shoe and I turned it upside down? Right. You kind of can guess. Unfortunately, machines do need that specificity. They can't generalize in the ways that we want them to. It's what we call machine reasoning, which is that a cup is a kind of vessel, right? And the vessel has an opening on one side. And if you tip the vessel over, whatever's on the inside comes out. We get that in like an instant. If we could figure out how to do some of these generalized learning things, apply knowledge from one domain to another, certainly we're trying, then it would lessen the need and the demand for labeling, which is a solution to the problem that we have to still teach it. We're not going to have this in the short term, like in the next few years. So in the meantime, if we're trying to accomplish short-term goals with machine learning, we're going to have to do the labeling. And as mentioned, there's increasingly specialization now among the firms. Companies like Labelbox are more of a platform provider, what they're calling labeling ops, right? Allegiant is focusing much more on video cases and more sophisticated cases, which will require more specific domain knowledge. Some focus on natural language processing. Our friends out in India, Desi Crew, that's like their thing. It's a nice space. We were not expecting the space to be so hot. What we did is we divided the universe of vendors into what we call this layer cake. It's like, okay, you have all these infrastructure vendors on the bottom, and then you have some enabling technology kind of one level above it, like computer vision and natural language processing. And then above that, we have these horizontal applications that we can build, like chatbots, which is an application of NLP. And then on top of that, we can do like domain specific stuff like financial services chatbot, which you build on top of a chatbot, which is built on top of NLP, which is built on top of the data. And what we decided is like, okay, we're going to start covering the market from the bottom up because it's a little bit of a inverted pyramid.
A lot of it.
A lot of vendors on the top, not as many on the bottom. And actually we had started with, we're like, okay, let's start with data prep and data labeling. And wow, that got hot unexpectedly.
Yeah.
We're like, wait, we haven't even gotten to the top yet. Okay, all right.
One of the questions I have intellectually is what happens to all of this labeled data? It doesn't go away. It's stored somewhere, and it's piling up as supervised learning makes its way through the economy in silos because it's all privately held. But at some point, as algorithms become more general and can feed across the silos, it seems that will provide some food for an eventual, I don't want to say AGI, but a more general AI system that can cross domains and different kinds of data. Have you thought at all about what becomes of all that labeled data? I mean, you're basically encoding human knowledge in the data, and that's valuable.
Mm-hmm.
Data in general is very valuable, and companies are holding that close. So they will not share that. And that is partially what is fueling all of this, that company A needs to label this set of data, company B needs to label a very similar set, and company C needs to do the same thing. They will not share that because that is their secret sauce, whatever, helping to differentiate them. And then as far as maybe one day, if we do share that, without machine reasoning, we really can't move to that next level that we need. We talk about the DIKUW pyramid a lot. So data is at the bottom, then information, knowledge, understanding, and wisdom. We can't get to that understanding level, let alone the wisdom level. So the wisdom is really, a human level, which if we're talking about AGI would be at that W level. We can't get to that K level until we get machine reasoning. So we're very far away. I know when we talk to experts in the field, you can get a wide range of responses to that question. Some people think we're a decade away, maybe 50 years, 250, maybe we'll never get there. And right now, we think until we get to that machine reasoning, we will not get there.
Although what I'm saying is you don't have to get to reasoning. Right now, an algorithm cannot operate on natural language data and then operate on pixelated images.
Right.
They're two different domains, but eventually one would hope you could develop algorithms that could move from one kind of data to another. And eventually too, I would think these silos of data will be open because after 10 or 20 years, they're not as valuable as they are right now to the companies involved.
Yeah.
What happens? Do people start dumping their data in this massive repository and then researchers can have their time with it, or what?
Well, a couple of interesting, man, you bring up so many great points here. A couple of things. First of all, if you think about sort of like how your brain works or any animal brain or even insect brain, the brain doesn't have one locus. It actually has multiple areas. It's like you have a part of your brain that processes speech. You have another part of your brain that processes image data, and you have another part of your brain that handles moving. And then, of course, the more sophisticated things like, planning and all that sort of stuff. And we know that because you have people that have actually brain injuries where a part of that brain might be disabled. They've lost the ability to say speak, but they can see, or they've lost the ability to see or process or something like that. Right? You'll see people have strokes who some people they're like accent changes. Like there's this weird sort of phenomenon where people develop a strange accent. It's unusual, right? But it shows that there's specialization, right? We might think, okay, well, that might imply that maybe we're not going to have a single algorithm. Maybe it'll be like algorithms that are really optimized for different things, but we do need sort of like the brain. So if the brain is not a single algorithm, maybe AI is not a single algorithm. Maybe it's something that coordinates between the different centers of learning and knowledge and somehow synthesize it. That might be machine reasoning. Machine reasoning might not actually be a new algorithm. Machine reasoning might be a way of coordinating between multiple algorithms and knowing how, which is the hard part. Knowing it's like, I'm seeing something, I'm hearing something. These two things relate to each other. You just bit into an apple and I can know what that is. That's what the reasoning is. I know what that is, right? Or some other synthesis, right?
My last question is about AutoML. You mentioned AutoML a couple of times. You have reports on AutoML. There are emerging these standalone no-code AutoML platforms. There's one that I'm familiar with. I'm actually trying to find somebody with horse racing data who can validate it with me to see if we can predict an outcome in a horse race. I don't code. And although I'm trying to learn, I'm in my 60s. I don't have any real expectations to be able to build things. But just as Windows abstracted from DOS commands, these no-code platforms are increasingly abstracting from the code base. Do you have a view of how that's going to develop? To me, that's pretty exciting. There's a very finite number of people in the world who can code, but everybody could use AI, or 80% of adults could use AI if it were simple enough.
So I think kind of two parts to this question. So first with AutoML and how we've seen the rise of this. AutoML has allowed individuals at organizations who may be very knowledgeable, take a data scientist, for example, to just do their job better, where they don't need to be doing everything manually anymore. They need to have some understanding of what is going on. You do need to interpret the results that come out, but I think that it's allowing people to do their jobs quicker and better. Maybe you need less people because of that. And then taking that one step farther with low code and no code tools, we have seen that companies are starting to deploy that for various use cases. And it's allowing people that aren't as technical. So maybe they're not the data scientists, they're a business analyst or, a sales rep or somebody in a specific role that's not very technical, a customer service agent, to go in and use some of that for their benefit. So they can go in, they don't need to be technical, and they can go in with, low code, do drag and drop and get the results that they need. So both of them are really shifting the market, different users for each.
Is certainly one of the goals of some of these platforms to democratize and to put AutoML in the hands of people who are not data scientists, not data engineers. And, hey, if you talk to Microsoft even, they'll tell you, where's Excel going? There's their whole Power BI platform. They're actually adding process automation into the whole platform. And if you could basically just drag a column down and say predict, right? So you could say horse races, right? So here are all the results. And then you have the name of the horse here, and their times or something, and then their results, and whatever other, you have to know what the factors are that have predictive value. That's where you get stuck, because even if I can give you the tools, I can't say, I don't know what actually predicts a win. Actually, if you knew that, you probably would not be talking to me on this.
Probably.
Well, except that's
you'd be out in your boats and
that's the power of ML, is that the more data you throw at it, the more accurate the predictions, and who knows what in the data is creating those predictions.
Well, certainly that's a vision. They would love for you to be able to have that spreadsheet and basically say, okay, predict the win. I'll put an extra row here, and then the value for win or loss, or maybe the probability of win, you predict that value based on everything. I don't think we're many years away from that. We may actually be a couple of years away from that.
Yeah. Well, actually, the platform that I'm fooling around with is called Accio. And I've got a guy who built a predictive model for the racing form. This is just a fun project, not that I expect to make money in the horse races. It's more to see the power of these platforms. This particular platform, the biggest use case, from what I can tell, are sales teams that have an overwhelming number of leads and don't have time to chase them all down and need a way of ranking.
Oh, yeah.
So my thought was, well, hey, if you could do it with sales leads, why couldn't you do it with horses? So we'll see. But it doesn't seem very far from the day when anybody who has a bunch of data can go to a no-code platform and do something, recognize a pattern or make a prediction. I mean, if you look,
it's good for tabular numeric data. I remember being very confused about AutoML because I'm like, I could just drag a bunch of images in there.
Right.
But not exactly. Now, it turns out that Google has, and Microsoft, and I think Amazon now, but Google had early this cloud vision AutoML thing where they had already pre-trained the network on just being able to, recognize things, right? But let's say you want to build a cloud identifier. This is actually the example they give, where you take a picture of the sky and it'll tell you what kind of cloud it is, physical clouds, not the internet cloud.
Yeah.
And it'll say cumulonimbus or whatever. They actually show that even though the model has not been trained specifically to do cloud recognition, you just put in like a very small number of images. I think it was something like 30 or 40. And then the system does its little transfer learning thing. And now you have a very specific model for it. And actually, in one of our classes, I have to note that one of the things that we do, one of the big things that we do here at Cognilytica is we spend time training organizations, surprisingly large ones. You might be thinking that they know what they're doing. The answer is they usually don't, on how to run AI and machine learning projects. And usually they get tripped up because they're so enamored with the building the model part that they sort of forget about the needing to collect and clean data, which is the not fun part. Sometimes they didn't even know what data they need to clean. They don't know what access they have to it. And they're doing things in the wrong order and they waste all this time and money. And there's a methodology, by the way, out there that optimizes for this. It's something called CPMAI, the Cognitive Project Management for AI methodology, which is itself based on a 20-year-old methodology called CRISP-DM. So CRISP-DM is old. It was good though, but needed to be advanced. So we advanced it, and others did as well. And one of the things it teaches you is to basically think big, start small, and iterate often. And this is actually one of those places that AutoML can help, which is that if you know what the problem is, you start small enough, you could start with a small data set. Maybe you're trying to build some insurance application that's trying to categorize the damage to roofs. And then you'd be like, oh, I need like 1 million images. And like, whoa, let's slow down. First of all, can you even recognize what the roof looks like? Start with AutoML, prove that you can do that. Or once that may be the thing. There's a bunch of things you need to do in between. But that methodology, which is like learning how to do things, like you go through 20 hours of instruction. It's like $2,500. It's like, trust me, spend more money doing it wrong than learning.
Oh, yeah. Right. More money and way more time.
Plug there. If you go to courses.cognilytica.com, you can go through that training yourself, self-paced and all that.
Maybe I'll do it. Yeah.
Would love to have you and all your listeners.
Yeah. Okay. This has been fascinating for me. You guys are very eloquent.
Well, thanks so much, Craig, for having us on. We really enjoyed this podcast, and we encourage your listeners to check out the AI Today podcast that Ron and I are hosts of, and in particular, the interview that we'll be doing with Craig.
Yes. So thank you all very much for having us on. We really do appreciate it. Fantastic conversation.
That's it for this week's podcast. I want to thank Kathleen and Ron for their time. As usual, you can find a transcript of this episode on our website, EYE.AI, that's EYE-ON.AI. Check out Cognilytica at www.cognilytica.com. And be sure to subscribe to the AI Today podcast, available on all the major podcast platforms. Remember, the singularity may not be near, but AI is about to change your world, so pay attention.